for 39 years this month. And you might think, as a person who is a major player with a national, sometimes international ministry, that most of my training was probably in seminary. None of my training was in seminary. I've been trained as a scientist, as a biologist, first in zoology at the University of Illinois, and then I've done some genetics work at the University of North Texas, and then some molecular and cell biology, terminating in a doctoral degree from the University of Texas at Dallas. So when I come here to talk to you how biology points toward God, this is what I have essentially devoted my life to. And the other thing that I have devoted my life to is that although 39 years ago we were on our way packing to come to Probe Ministries in August, and by the way, August is a bad time to move to Dallas from Illinois. We'd never experienced hot like that before. But 40 years ago today, before friends and family, Sue and I were united in marriage. This is our 40th anniversary. So this lady has been, as you can tell, the tones that she is wearing are bright and sparkly. And what I am wearing is subdued and outdoorsy, and I've got my eagle tie on today, which I just got recently. And as I like to say, I'm a critter guy. I love God's creatures, and one of my favorite contemporary songs from Chris Tomlin, although Laura Story wrote it and he performed it and it made it well known, the song Indescribable. The first verse just basically says, from the highest of heights to the depths of the sea, creation is revealing His majesty. And from the colors of fall to the fragrance of spring, every creature is unique in the song that it sings, and that song is to our Creator. And it's always been fun for me, as whatever organism, whatever animal, plant I'm studying, I can delve into and see what unique song it is singing to its Creator, because the creation praises God simply by being and doing what it is, what it was designed to do. And I want to open today by looking at a passage of Scripture in this regard that might be familiar to you. It comes from Romans chapter 1, and I like to consider Romans Paul's theological defense of the gospel. And he begins here in chapter 1 by saying something quite interesting. He says, "The wrath of God is being revealed from heaven against all the godlessness and wickedness of men who suppress the truth by their wickedness." That's interesting. Apparently, there is something that is real and that is true. Apparently, all men and women know what this truth is, but yet there are many in their godlessness and wickedness are suppressing this truth. It goes on in verse 19. He gets a little bit more specific. He says, "Since what may be known about God is plain to them." So think about that. What they already know, and he's talking about everybody, it's plain. It's not complicated. It's obvious. It's right in front of your face. It's plain. And he has, because God has made it plain to them. Now that adds a little bit extra twist, because it tells me that God has gone to some specific effort to ensure that whatever this truth is, it's plain to everyone. Other translations say because it's evident to them. It's clear. You don't have to think about it. Well, what is he talking about? Well, he continues in verse 20. "For since the creation of the world, God's invisible qualities," so there are things about God himself, his eternal power and divine nature, so certain things about God's nature, his power, have been clearly seen, being understood from what has been made, so that men are without excuse. he's saying something very clear here that, excuse me while I kind of readjust there a little bit again. There we go. That's better. It's clear. Oops. Sometimes that's not so clear. There you go. Is that better? Yeah, okay. It's clear to me now. Things that God has made since creation. There are things that we can know about God's character, about his nature, about his power by simply observing God's creation. In other words, it says, open your eyes. Look at the stars at night. Look at the critters that are walking around as you walk through the grass, the insects, the gophers, the squirrels, the bobcats, the link, everything. They are exclaiming in a very plain language to all people certain aspects of who God is. And that's what and for me today, in this age, to me, we're discovering so many things that point to God that it's a blessed time to be a Christian. Because from my perspective, never has it been even more plain than it is today. And sometimes it's very plain and uncomplicated, and it's available to everyone. What I'm going to do with a few things today is I'm going to open the door to a little bit of the complexity. Because sometimes God's power and his divine nature is even more expressed in the details. Okay? So we're going to talk about this idea of intelligent design. You may have heard the phrase, maybe you've read a book or two or something. Let's just talk about what it's not. It's not the latest version of creationism, because intelligent design is a little different. With every version of creationism, you begin with an understanding of Genesis particularly, and the Bible as a whole, and this is your theological beginning or foundation. And from that foundation, then you look into the world of science, look into the world of nature, and you see how that fits together with your particular theological perspective on Genesis. Intelligent design is different. It does not depend on any theological understanding of Genesis or of the Bible itself. We look at the scientific evidence first, and we simply look for the evidence of design. Is it plain? Is it clear? What is it telling us? How can we describe it as being intelligently designed? And whatever your theological perspective, well, that's something you add later. People always ask me when I speak in public forums, at universities, wherever, eventually, who do you think the designer is? Well, I'm clear. Well, yeah, I'll tell you that. But first you have to understand that the science alone doesn't tell me that. Nature itself doesn't identify the designer to me. It's only telling me certain aspects of his nature and his power, but not necessarily who or what it is. Then I have to add my own philosophical, theological perspectives, and for me, this scientific evidence lines up perfectly with the God of the Bible. So what is intelligent design? Well, first on the negative side, intelligent design is an intellectual movement that challenges Darwinism, or Darwinian evolution, and its dependence on purely natural process, either random or chaotic mutations, as you might call it, coupled with selection. That is what has brought about all of the diversity of life that we see today. A purely natural process by which God was not necessary at all. On the positive side, intelligent design is also a scientific research program that investigates the effects of intelligent causes. The effects of intelligent causes. And now I'm going to make you think a little bit here, so everybody wake up now. What are the effects of intelligent causes? Well, they are effects of high specificity coupled with extremely small probabilities. You got all that squared away now? You know what the effects of intelligent causes are? Yeah, that's a bit more technical kind of language. But my favorite example, as I list there for you, is winning the lottery. A couple of years ago, I was in San Diego doing a presentation similar to this one. And I simply asked from the audience, and is there a lottery here in California? They said, oh, yeah. Well, what are the basic odds for winning the lottery here in California? A guy in the front row was in a church, said, oh, yeah, about 1 in 23 million. Just right on the tip of your tongue. So, Yeah, approximately speaking, I haven't bought a ticket myself to check the back and what the odds are, but I'm just taking his word for it. It's something like 1 chance in 23 million. Now, usually when the lottery begins on a particular week, it's a low amount, like what, $3-4 million, and if nobody wins, they up the amount of money. When they up the amount of money for the lottery, what happens to the number of tickets they sell? More or less as the lottery goes up? Well, more people buy tickets. The odds are the same, but the more tickets you sell, the more likely it is that somebody will win. And basically, statisticians will tell you if you sell around 10 to 11 million tickets, somebody's going to win because you've now reduced the odds to about 1 chance in 2 that somebody will win because you've had enough things sold, enough numbers chosen, and so forth. What that means in statisticians' language is you have enough probabilistic resources. You have enough out there to make the winning of the lottery possible. So even though it's quite improbable, 1 chance in 23 million, it does happen with some regularity because you end up selling enough tickets. Well, but let's drastically lower the probability and dramatically raise the specificity here. Let's just say you have a neighbor who's always played the lottery every week from the time it started. Never wins. Just buys 1 ticket. They're a Calvinist. If God has ordained you to win the lottery, how many tickets do you need to buy? Right? Just 1. Why bother increasing the odds by buying 10? It just takes 1 if God wants you to win. I'll let you think about that. But one day, your neighbor finally wins the lottery. He wins $4 million. And he goes running out of the front of his house first thing in the morning, and he's just throwing, I won $4 million, and he's just so excited. And you, if you know your neighbor, you suddenly get a little excited too, because that fence dividing your property has been kind of broken down, and maybe he'll finally fix it, and maybe he'll just throw a big party and just start throwing out $100 bills, and maybe I'll get a few of those. Well, you get excited. That's a little more specific to you because it's your neighbor. But the lottery commission just finds the ticket and looks at it. It's an official ticket. You win. Here's the money. No big deal. So this is not going to be a big deal to the lottery commission, but let's raise the specificity even more. Let's say your neighbor wins the lottery one week. He wins it the week after that, and then he wins it again the week after that. He's won $4 million 3 weeks in a row. And in his big party, he informs you that he used the same set of 6 numbers to win each time. What's going on in your mind? Do you think that was all by chance? Or do you have some other things rumbling around in here? You can go ahead and say it. What do you think? Okay, I'll say it for you. You're all suspecting cheating. That's what you're really thinking has happened here. And why would you think that? Well, you're suspecting really intelligent design. There's a very specific outcome. Same person, 3 weeks in a row. Highly improbable that it would happen, but yet there it is. But immediately what you're suspecting is somebody has manipulated the system. Someone somehow has intervened intelligently to ensure that this set of numbers wins 3 weeks in a row. What's the odds of winning 3 weeks in a row? Well, you take that probability, 1 chance in 23 million, and you multiply it by itself 3 times, which is this number. 1 chance in about 12 septillion. So, here's a million, then a billion, trillion, quadrillion, quintillion, sextillion. 12 sextillion. What? Never been enough people in the history of humanity to sell enough tickets to make this possible. The Lottery Commission will investigate. They won't bother calculating out the probabilities. They are going to investigate immediately. They're going to be suspicious after the second win. But on the third one, they're practically going to come to the guy's house and show up with handcuffs. Okay? Because they know you don't have enough probabilistic resources for this to happen on its own. Well, in nature, these are the kinds of events that we're looking for. Things that are so highly improbable, where we can actually calculate a probability, but yet they are so specific. In other words, meaning it has to be just this way or it doesn't work at all. Highly improbable, but as you look into nature, you look into living things, there it is. That's the mark of intelligence, is what we're saying. You also can see this in a couple of other different ways. If any of you have ever been to Mount Rushmore there on the left, you can recognize the faces of 4 U.S. presidents. You've got Washington, Jefferson, Roosevelt, and Lincoln. And you can tell by the color of the rock compared to the other rocks around it. This is recent. It's been recently exposed. It's nice and white. Everything else is gray. And you see all the jumble of rocks that were chipped away below it as a result of carving these faces in the side of the mountain. And not for a single second are you tempted to think that Mount Rushmore happened by rain, wind, storms, and earthquakes. And no, that was intelligently manipulated. You know that intuitively. We make these kinds of decisions all the time. But the one on the right is the old man in the mountain from New Hampshire. And in the right kind of light, from the right direction, at the right time of day, you see the outline, the profile of a man's face. He's got a big forehead, big nose. You see his mouth and a really strong chin. It's rock. I mean, it's a strong chin. But if you were looking straight on at the old man in the mountain, you wouldn't detect a face at all. It's natural. There's no human interference in making sure that happened. It's just the way it is. And in fact, in 2003, the old man in the mountain's face fell off the mountain. That's kind of what happens to naturally, with the appearance of design here. It's not really design, it's just the appearance of design. And there's a real distinction. So as humans, we make these kind of distinctions in our mind all the time. So let's talk about biology now. Biological design. Here's a couple of quotations from 2 fairly well-known scientists. The first one is a man named Richard Dawkins, who is what I would call not just a militant atheist, he's an evangelical atheist. He's been publishing books promoting scientific atheism now for several decades, well-known. And he wrote a book back in 1985 called The Blind Watchmaker. And on page 1, he says, biology is the study of complicated things that give the appearance of having been designed for a purpose. That's a rather clear admission that when he looks at living things, they have the appearance of design. Now, he's going to spend the remaining 300 so pages of his book explaining to you why it's not designed and how he thinks it all happened naturally. But on the front end, he's admitting things look like they're designed. Seems to me like somebody is suppressing the truth. Sound familiar? Then there's Francis Crick, who was the co-discoverer of the structure of DNA. Biologists must constantly keep in mind that what they see was not designed, but rather evolved. So you're sitting there in the laboratory, you're looking through your microscope, and you're, not designed, not designed. You got to keep telling yourself that. Why? Because living things look and act as if they are designed. They look it. And for those of us in the intelligent design movement, we simply say, well, if it looks designed, maybe it is. Just give us a shot. Maybe it is. But again, two men here who seem to be suppressing the truth. Then there's this concept, irreducible complexity, was introduced by Mike Behe in his 1996 book called Darwin's Black Box, really took the academic world by storm. It actually was reviewed in Science magazine, Nature magazine, the first time something like that had ever happened for a book like this, because he's a biochemist from Lehigh University. He's got a university appointment. He was tenured, still is. He still works there, still does research. Scientific community had to take a look at what he was saying. He said something is irreducibly complex if it is composed of two or more necessary parts. Remove one part, and function is not just impaired, but destroyed. And it's interesting now, in the standard scientific literature, this phrase, irreducible complexity, has been showing up. Oftentimes they don't reference Michael Behe, but he originated the term. It didn't exist in literature before, but all of a sudden now, about 20 years later, the phrase irreducible complexity is starting to pop up in the regular scientific molecular biology literature. But he offered a specific example of this. He said a mousetrap is irreducibly complex. Mousetrap has 5 parts. It has the platform, the wooden platform that holds everything together, everything's attached to. It has a holding bar, it has a spring, it has a hammer, and it has a catch. The holding bar and the catch are what you use to set the trap. So this trap is not set, and you would have to take the hammer here and bend it against the force of the string over here, place the holding bar on top of it so it stays in tension, and then just lightly connect the holding bar to the catch, which is where the bait is attached, so that when a mouse comes along and starts to nibble at the bait, it just lightly jostles that catch, releasing the holding bar, and there goes the hammer. Now, you need all 5 of those parts for the mousetrap to work at all. If you have everything but you don't have a holding bar, you can't set the trap. If you've got everything but you don't have a spring, well, there's never going to be any. You can set the trap, but when it jostles, ain't nothing going to happen because there's no force involved. If you don't have the platform, well, you got all these 4 metal parts just jangling around in a brown paper bag or something. They ain't going to catch no mice, you know. It ain't going to happen. So what he says is that a mousetrap is irreducibly complex, and you cannot build one by natural selection. Natural selection is a process, as Darwin defined it, that changes things almost imperceptibly from one generation to the next. And it's a fine-tuning process, if you will, always perfecting, always building. Well, if all you're starting with is a platform, how many mice are you going to catch? None. Oh, okay, you got a platform and a spring. How many mice are you going to catch? Still nothing. Okay, let's add the holding bar. Now, no, still nothing. All right, we'll add the catch. No, because if you don't have a hammer, there's nothing to catch them out. You can't build something like this by natural selection because all the parts have to be there at the same time in order for there to be any function. You might cobble a few pieces of the 5 pieces together, and it may not be terribly efficient, but it might still work most of the time. Now, natural selection can work with something like that. Natural selection can work with that because, well, you know, it's you can fine-tune it because it's already there. It's already functioning. Okay? Well, as I said, if it looks designed, maybe it is. And the bacterial flagellum is something that Behe talked about. It's a very, very small molecular motor on bacteria, and it's what they use to propel themselves through water. Technically, the flagellum operates in a corkscrew kind of motion, and it can rotate at about, in some species, about 100,000 revolutions per minute. Think about that. It can stop within a quarter of a turn and then completely go into reverse direction at 100,000 RPM. If you tried that with the human-designed rotary motor, which is like an outboard motor on a boat, it'll blow up on you. We're not even close. It's got the same kind of design, it's got the same kind of features. One scientist referred to it as the most efficient machine in the universe. It has a flagellum, it's got the rotary motor, it's got a propeller, universal joint, stator, rotor, bushings. It's got everything that we put into a rotary motor, but these are all tiny, tiny, tiny molecular proteins. And it's amazingly efficient. I'm not even giving you all the details. There are over 40 proteins involved in most flagella. Take any one of those 40 away, and either the flagellum isn't made or it simply doesn't function. You've got to have all of them there. How do you build a flagellum by Darwinian evolution is the question. The answer is you can't. Because you can't just take a bunch of proteins doing other things in the cell and somehow force them to come together and expect a flagellum to work. It doesn't happen that way. It's simply not possible. Okay. It is irreducibly complex by Michael Behe's definition. I love this quote from a Japanese scientist. He says, since the flagellum is so well designed, I'm surprised that word got in the article, and beautifully constructed by an ordered assembly pathway, even I, who am not a creationist, get an awe-inspiring feeling from its divine beauty. Once again, I think we've met somebody else now who is suppressing the truth. He sees it. He says it's designed. He says it's beautiful. He gets this awe-inspiring feeling, and he even uses the word divine, which he puts in the scare quotes. I don't really mean divine, but it's just the best word I could find to describe what I'm sensing here. It's a divine beauty. It's an amazing statement. Studying just this tiny, tiny, tiny little molecular machine in cells. And we've now discovered that our cells are filled with such molecular machines. Now let's go back to this complex, specific complex stuff, and let's try to make sure we understand this a little bit better. In this photograph are two assemblages of rocks. The ones in the background is a huge compilation of literally thousands of basaltic rocks on a volcanic beach in Hawaii. You find lots of black sand beaches in Hawaii in various places, different islands. And that large assemblage of rocks on the shore in the background is hugely complex. Highly improbable arrangement of those rocks. If you took all of those same rocks and pulled them out of there and then just tried to repeat that same grouping. So that looked exactly the same. You just started throwing the rocks back in or dumping them back in. It'd take you wouldn't have enough time to do enough trials to get there. It's hugely complex. You couldn't repeat it. But there's nothing specific about it. It doesn't mean anything. It's just a bunch of rocks, right? So yeah, it's improbable, but there's nothing specific about it, so that's no big deal. Now you look into the foreground and you see this, what looks like a circle of rocks, far fewer, maybe about 30, maybe 40 rocks total. I never bothered to count them all. It looks like it has a little entryway right over here. There's a break in the rocks. It kind of looks like something people would arrange so that we could all sit around a circle. Maybe at one point they had a fire in the middle, who knows. It has the appearance of being designed. There's a specificity to it. It's a circle. If you actually measured it and did all the mathematics with it, it's probably not a perfect circle, okay? I'm not going to go that far with it. But it's a close enough approximation that, well, yeah, it looks designed. But you know, we might have an interesting conversation because, well, there's not that many rocks there. You take several of those rocks away and you're still going to see the circle. Is that irreducibly complex? Well, I'm not entirely sure. So you're thinking about this, what kind of experiments can you do? How do we calculate with the probability of this formation and all sorts of things. And you're walking along the beach and suddenly you come across this. How did that get there? Is that just a chance assemblage of waves and wind and rain and you're laughing? You don't think so? Well, what you see is something that is intelligent. It is intelligently designed. Someone took a stick and drew very specific symbols in the sand, arranged those symbols into 3 groups of symbols, and the 3 groups of symbols are themselves arranged in a sequence to communicate a message. Information. John loves Mary. Do you know if the statement is true? No. Maybe John hates Mary. Maybe it's Mary's wishful thinking, you know? Maybe it's somebody trying to get John in trouble. You don't know if it's true. Do you know who wrote it? No, you have no idea. You don't even know if John and Mary are referring to actual people or not, because they're not. I wrote that in the sand. But you know it's intelligently designed. You know it took an intelligence to bring about this formation, this grouping of symbols in the sand. It doesn't happen naturally. Nature does not have the capacity to produce this kind of assemblage of very specific symbols on its own. The probabilities would be astronomical. So we're talking about biological information. When we talk about information and language, we use letters to construct words, words to construct sentences, sentences to construct paragraphs, chapters, eventually a book, and we assemble books together, usually in an organized fashion. Sometimes the person who organized it is the only one who knows what the organization is, but he knows where every book is. My libraries tend to be like that. And then you put the books together, you've got a library. But there's an organization structure to each one of those levels of the hierarchy. Well, it turns out in biology, we have exactly the same thing. We don't have a 26-letter alphabet. We have a 4-letter alphabet, 4 nucleotides. We'll just abbreviate them GCAT. In the DNA molecule, those are arranged in a sequence. And in all DNA molecules, there's a second sequence that's complementary, because an A always pairs with a T, and a G always pairs with a C. So if you know the sequence of one string of DNA, the single strand, you can predict the sequence of nucleotides in the second strand of the DNA. We group nucleotides together in groups of 3. Those 3 nucleotides are called a codon, because each one of those codons, and there's 64 of them, codes for a specific amino acid, of which there are 20. And the sequence of codons in the DNA is what determines the sequence of the amino acids in a protein. We have some very specific language terminology we use for that, because the process in the cell goes from DNA to RNA. We call that transcription, because the language in the RNA is basically the same. So DNA gets transcribed to RNA, but RNA is translated into protein because the languages are different. That's the terminology we've used from the very beginning. They're language terms, not because it's a nice analogy, but because they accurately describe what's going on in the cell. You have at least 2 different languages operating in all the cells of your body all the time. Literally, millions of these kinds of reactions are happening in your body every microsecond. It's really fast stuff. So we group the codons to make genes, and we group the amino acids together to make a protein. So it's like the sentences in our own language system. But then genes and proteins are brought together to make chromosomes. You've got 23 pairs of them, all of you. And then the chromosomes are grouped together to make a genome. 3 billion of those nucleotides in the single-strand DNA of all your cells. 3 billion of them. Okay. More information stored than in about 100 or so libraries of Congress in just one cell. One. Lots of information. We know that said DNA is transcribed into messenger RNA. Messenger RNA is translated into protein. Dozens of transcription factors regulate the process. There's even sometimes a 3D arrangement of chromosomes in certain tissues to make sure different pieces of DNA and RNA are stuck together to make the right protein. Just amazing that chromosome 5, 8, and 12 can somehow come in three-dimensional proximity, and the protein needs pieces from that DNA on chromosome 5, that piece on chromosome 8, and that piece on chromosome 12, and somehow your cell knows how to get those three chromosome pieces close to each other. You have a clue how the cell does that. We have promoters, enhancers, repressors, all kinds of factors on the DNA itself. And the rest of the stuff that codes for protein is only about 2% of your total genome, of all your chromosomes. But now they used to think evolutionarily that all the rest of it was just junk. It's evolutionary holdovers from all of our evolutionary history. It's not useful, it's not doing anything because it doesn't code for protein. But now we've discovered that almost all of that is being transcribed into RNA for some kind of function. And we don't even know what it is. So some of you really enjoy biology, some of you young people, let me tell you, there are things that we're opening up questions that we never even dreamed were there. There is so much now to research, to understand of how our bodies work, how they function, how the DNA is used, and how this so-called junk is influencing how the DNA itself is used. We don't know how it all works. Well, I love this quote from a guy who helped sequence the human genome. We're deliciously complex at the molecular level. We don't understand ourselves yet, which is cool. There's still a metaphysical, magical element. The system is extremely complex. It's like it was designed. Maybe it was. Let's consider the option. He says, there's a huge intelligence there. I don't see that as being unscientific. Others may, but not me. Here's a scientist who's on the fence. He says initially it looks like it's designed, but in the second part of his statement, he's admitting there's intelligence here. He's not putting a person to this intelligence yet, and he's concerned about some people thinking he's being unscientific. One last example of design. I love woodpeckers. Woodpeckers are strange creatures. They bang their heads in the trees. Did you ever think about that? I mean, that's how they make their living. Why do woodpeckers bang their heads in the trees? What's that for? Just because they like it? They like the headache it produces? Well, they're looking for food. They're looking for insects. Some, like this pileated woodpecker on the left, he really just kind of pushes away pieces of bark and looks for insects underneath. But this is the green woodpecker from Europe, and he literally drills a hole into the tree to expose tunnels made by insects or insect larvae, and it's the insects inside these tunnels that he's looking for. Sometimes they just kind of poke on the tree until they get a hollow sound back. That's where a tunnel is, that's where I drill the hole. Some can just simply listen, and they can hear the movement of the insects, and they know where to drill their hole. So they're looking for food. And when they expose the tunnel, they insert their tongue, they got a sticky saliva, they got little barbs on their tongue, and they kind of go up and down, and there's breakfast. But you notice a number of things about woodpeckers. Notice how the bottom of the tail is pushed up against the tree, because now it's acting like the third leg of a tripod along with its 2 feet to give it stability on the vertical surface as it bangs its head in the trees. If you look at the bill, right behind the bill and in front of the skull is a shock absorber of muscle and cartilage to absorb the shock of bang. Because when you watch a woodpecker, man, they're hitting that tree hard. And then it's also very rapid. We call it drumming because it sounds almost like a drummer's drum roll. It's so fast. And that's because there's a very complicated network of nerves and muscles in the back of the head, the shoulders, the neck, to guide that very, very rapid movement. We as humans, we're not designed to do that. You ever try that? I can already hear my brain just kind of sloshing back and forth. They have pads on the inside of their skulls so that the brain isn't constantly banging into the inside of the skull. That's what concussions are. You don't want that, okay? But those aren't the most amazing things about woodpeckers. I told you they stick their tongue into the tree because woodpeckers can extend their tongue 3 to 5 times the length of their beak. It looks kind of gross at the moment, doesn't it? Okay. Well, how do they do that? I mean, it's interesting to see the bird sticking its tongue out, but when it comes back in, where do you put it? Where does it go? I'll show you. So here's the tip of the tongue. This tongue is extended, so most tongues it's a muscle attaches to the lower jaw. Not so in birds, especially not in woodpeckers. And it makes a loop down beneath the skull. Actually, if it was not extended, it would loop down like this. And then it comes around the top of the head. It divides in half going around the back of the head, but comes back together between the eyes and inserts into the right nostril of the upper bill and extends all the way to the inner portion, the tip of the bill. And when it wants to extend its tongue, if you see here, there's a hyoid bone in your tongue. So the woodpecker has a hyoid bone, and it follows the same route. And you can see here, the bone even inserts into the nostril. Well, it flattens out these big loops, and the tongue is a muscle, so it contracts and outshoots the tongue 3 to 5 times the length of the beak. The question is, how do you build something like that by natural selection? If you make just a slightly longer tongue with one mutation, but you don't have a retraction mechanism at the same time, well, the first time you go to drill a hole, you cut the tongue off. That's not a selective advantage. So you have to not only evolve a long tongue, but a retraction mechanism at exactly the same time. And I'm going to close with this quote from Richard Lewontin, who is a Harvard geneticist. And at the end of he reviewed one of Carl Sagan's last books, and he made an amazing admission. He says, "We take the side of science in spite of the patent absurdity of some of its constructs, in spite of its failure to fulfill many of its extravagant promises of health and life, in spite of the tolerance of the scientific community for unsubstantiated just-so stories." And what he means by that is sometimes we just create a story about how we think something evolved, but there's no evidence for it. But if the story sounds good, that's how it probably happened. He says, because we have a prior commitment, a commitment to materialism, it is not that the methods and institutions of science somehow compel us to accept a material explanation of the world, but on the contrary, we are forced by our a priori adherence to materialism or material causes, we're forced to create an apparatus of investigation and a set of concepts that produce material explanations. What he's saying is that we have crafted science so that it produces material explanation. No matter how counterintuitive, no matter how mystifying to the uninitiated, moreover, that materialism is absolute because we cannot allow a divine foot in the door. Why does he accept evolution? Because I am a materialist, first and foremost. I simply cannot, will not allow any divine intervention. No matter how ridiculous some of our ideas are, our solutions are just so stories, it doesn't matter because materialism is all we're going to allow. Well, I'm going to have a Q&A time. I'll play this video a little bit later, but as I'll just say, the date is coming our way. Stay tuned. Thank you.